Hi, good morning, everyone. What a wonderful Saturday today. We are entering to the 19th webinar on various electrical safety, electronic equipment webinar, and various subjects related to electrical safety. Today, 6th of October, we are doing two-part webinar on lightning protection for electronic equipments. All of you know the surge and lightning damages to electronic is a frequent occurrence. Lightning can strike the air conductors directly and surge voltages even from kilometer away. Even from a kilometer away, it can enter your installation. The surge voltage is then passed through ground through the equipment, which can lead to damage, complete destruction of your equipment. If you do not follow the international standards, if you do not follow the best practices, this is what happens. Lightning typically damages the electronic in two ways. The first is a direct lightning striking to the building, which is an infrequent occurrence. A direct lightning strike will cause significant damage to electrical and non-electrical items in the premises. In many instances, there is a huge fire started due to lightning also. Today, we are going to understand the reason for the failure of electronics due to lightning. As you all know, the entire initiative of electrical safety webinar is an initiative of Cape Electric, who has been continuously trying their best to educate and create awareness about various international standard and standard that India should practice because our cultures are different completely. Most of the incident that occurs is all because of our ignorance. वो चलता है attitude that we have. मेरे को कुछ नहीं लगता है. Nothing going to happen to me and my building. So why I should care? Why I should change the wire? Why I should have the protection equipment in the building? Because I pray to 10,000 gods. God will protect me. So this is the attitude that we have. You've seen the recent fire in Bhopal where 8 people died. Out of that, 4 are the inpatient and 4 are the hospital staff. What caused the fire? There are various, because once the building is burned down, it's very difficult to point a finger at the reason for the fire to start. Nobody can identify exact, but in our study, the experience of 30, 40 years of experience, 80% of the time is poor electrical installation in the building has caused the fire. It was a big learning. Hope the Madhya Pradesh government will wake up and ensure that they practice a safe electrical installation in the building. All of you know Cape Electric, and I would like to highlight two important things that in 2019, Global Earthing System interconnecting EHV, HV, and LV and ELV system for large industrial and commercial installation for smart city was introduced. In 2022, they have introduced a digital platform for safe operation of voltage electricity called Solve LV. So we will talk more about it after our speaker, Gopakumar, present the topic. Leading the market with right solution is their motto, and the team in Cape Electric are continuously trained to provide end-to-end solution from design to implementation rather than selling a product for the customer need. This is the practice that they do, and since they have been very generous in creating a lot of awareness, I would just wanted to introduce the product that deal the best in the world. And They are one of the best known electrical company specialized in protection, fire safety, electrical safety protection equipment they have. So these are the lightning protection and earthing system they deal with, and surge protection devices. And this is the solve that that has been introduced this year. All of you know, Gopakumar is a missionary in preaching the safe electric practices. Having more than 28 years of experience in electrical safety, lightning protection, EMI and EMC, etc., carried out hundreds of studies on failure analysis of electronic equipment and hundreds of electrical accident analysis, including various fire accident from electricity. He has conducted more than 1,000 training in various countries on subject of his expertise. Mr. Gopakumar is a member of National Building Code 2016 Electrical Committee and responsible for IS and IEC 62305. He is also the member of working group, the technical committee in IEC, and responsible for international standards and guides for lightning protection for structure, person, installation, and content, as well as lightning hazard preventive measure. Ladies and gentlemen, I would like to welcome Sri Gopakumar. I would request all the audience who are present here, if you have any questions on that, whatever your question should be very particular to the topic that we are discussing today. I would request everyone to post only into the Q&A. If you put it on chat box, that will not come into our record, because some of the questions are maybe very important. When we finish the webinar, we want to reply to them. We will not be able to reply to you in person because we do not have your email ID. We do not have the chat record. So I would request all the participants to post your question only in Q&A box that you find on the bar. And we'll be posting our speaker's email ID, which you may note, and also the product, the deal. I would request to encourage Cape Electric, because you have not seen many electrical safety companies who are preaching on knowledge. So I would urge, my request to everyone, give your preferences to Cape Electric because they have the world-class product. And Mr. Gopakumar, one of the best known brain in the country on electrical safety. I now welcome Mr. Gopakumar to do the presentation on the same.
Thank you very much, Mr. Dominic. I hope my screen is visible.
Yes, sir.
And it's a full screen.
No, sir. We can make it full screen.
Now it's full screen.
Yeah. Now it's full, sir.
Yeah. Thank you. Thank you very much for the nice introduction. So today also we have a lot of participants as usual. Last time we had more than 200 at the beginning, and today we have more than, I think, 140 at the beginning. So let me start the presentation. We are going to discuss about the surge protective device, SPDs. The SPDs internationally, the IS, the IEC sectional or subcommittee 37A is creating standards on low voltage surge protective device, and you can see here. So there is a letter missing. Working group 3 and working group 5. These two are the groups, those who are making standards on low voltage SPDs for power line. We have been in the field of surge protective device since 1997. I still remember one of my first industrial visit in Tamil Nadu to a place near Trichy, to a paper mill. This paper mill was having a problem. It was a variable frequency drive, and the drive was tripping unnecessarily. It was a large drive, probably about 200 kilowatt or so. Whenever there was a switching, capacitor switching on the high voltage side of the the transformer or on the substation, this drive was tripping, and this drive tripping was creating a big problem to the industry because the whole process was shut down. Then they have to clean the machinery, they have to restart the production. So it was a wastage of material plus a lot of time waste. So then what happened is at that time, industry doesn't know what is an SPD I'm talking during 97 or 98. So we installed our first SPD for an industry. Of course, before that we were doing it for wind turbines, but that was our first experience. And finally, we could solve the problem. The customer was so happy, and nobody expected that an SPD is so efficient in stopping the tripping of a variable frequency drive. Now, coming back to the presentation, international standards. Surge protection is carried out based on two main standards. The first one on the left side is SPD standards. So there are standards made by SE37A, which is basically for the low voltage, that means up to 1000 volt AC and 1500 volt DC application, for power line, for data line, for signal line, and for solar PV. You can see the standards name 61643, 11, 11 or 21, 31. These are for requirements and test method, and 12, 22, 32. These are the selection and application principles. So these are about the SPD standards. And when you install an SPD in a line, in an installation, you also should look into the standard IC 60364 which talks about the selection and erection of electrical equipment, device for protection for safety, isolation, switching, control and monitoring. Especially SPD is also explained here. So when you select or when you install an SPD in a low voltage line, we also should take care of the requirement of these particular standards. So in these two seminars, part 1 and part 2, we will discuss the various requirements from these standards. But of course, 2 seminars are not enough to create the complete awareness, but we will try to make it as best as possible. Now, coming back to the concept, it is nothing but equipotentialization, not only for electrical safety, the concept for lightning protection system, the concept for SPD, everything is based on equipotential bonding or equipotentialization. So how best you make the equipotentialization is finally deciding whether your electrical installation is safe against touch voltages, safe against lightning, safe against surges, and so on. To start with, I will explain with a small example and then try to analyze how the problem can be solved. What you are seeing in the picture, imagine in your house, you have an appliance, some electronic appliance, and this appliance is class 1 appliance. You have a line connected to it, you have a neutral connected to it, and you have a PE conductor, earth wire connected to it. First, we should understand, I'm just trying to explain the definitions of voltage, which is related to transient over voltage protection. Because the protective devices, like all other protective devices, such as OCPD, RCDs, and other devices such as AFDD, these are operating in series. It disconnect the current, whereas SPDs are devices which are connected in parallel to the line. So this is very important to understand. So these are voltage operated devices. So voltage and the voltage parameters are very important or the first important point to find out the performance of SPD and its application. So in the standard, the first one is nominal voltage. Nominal voltage is nothing but the normal voltage, 230 volt, for example. Under this condition, your appliance is 100% safe. Maximum expected voltage, you know very well that 230 plus 10% or plus or minus 10%, we say generally. So let us assume that plus 10%, this is the maximum voltage which can come into or between line to neutral, and under this condition your appliance must be safe. Any voltage more than 253, let's say for example 260, 270, 280, 300, these are actually not the normal voltage, or these are not the maximum continuous operating voltage. These are voltages which can come intermittent for temporarily due to some problem in the line for certain time, not for a longer time. So under this condition, probably your electronic appliance is able to withstand, let's say, for example, 15 minutes. Higher voltage, 320, 350, 400, 440 volt, again higher voltage. Under this condition, still your equipment probably may withstand a few minutes. Example, 1 minute. Again, up to 1000 volt, 1200 volt, your equipment may withstand up to 10 seconds. This is an example. Now, we must also understand that these are line to neutral, but between line to earth, due to a high voltage fault, all equipment which we connect to a line must be able to withstand the 1200 volt plus nominal voltage, means about 1450 volt between line and PE for 5 seconds. This is a standard requirement. Now, what I wanted to tell you is, under normal condition, your equipment is safe. Under maximum continuous operating voltage, your equipment is safe. Under temporary over voltages, your equipment may withstand certain time depending upon the voltage. Now here, we have two solutions to protect the equipment. The first solution is, probably the equipment is able to withstand that particular voltage. Instead of 10 seconds for 1200 volt, let's say it can withstand 1200 volt continuously, probably a special device. So this is one technique which can be applied to protect the appliance. The second technique which can be applied is, you disconnect the supply. In case of any temporary over voltage, let's say for more than 200 milliseconds, you disconnect the supply. In order to protect the equipment, two techniques which can be applied is, one is the equipment can withstand these high voltages. Number two, if the equipment cannot withstand, you disconnect the supply. Similarly, even a higher voltage, let's say in the range of kilovolts, 2 kV, 5 kV, 10,000, 30,000. So once when the voltage is again more and more, you can see here, it may withstand 100 millisecond in one case. It may withstand 10 microsecond in one case, and it may withstand 1 microsecond in another case. So depending upon the transient voltage, these are transient voltages. The equipment may be able to withstand for a short time, and immediately after 1 microsecond, for example, it may fail. These are examples I am explaining just to create a background how SPDs are working. The two ideas which can be implemented to protect the equipment is, first, equipment shall withstand. Equipment manufacturer decide that I make an equipment which is very, very strong against transient, so my equipment is able to withstand. I don't need anything extra. So this is one idea which can be implemented. And the second idea is, you limit the voltage less than its withstand voltage. Very important. See, in the previous case, the time is more. You have time to disconnect. Whereas in the second case, transient over voltage, you don't have enough time to disconnect, because before the line is disconnected, for disconnection, you need some device to operate. Before the disconnection happens, the voltage, the withstanding time is quite less. So the technique to be applied is, limit the voltage. Don't make it more than certain level. So for example, instantaneous, within a short time, in nanoseconds, for example, you limit the voltage. As a result, once when you are limiting the voltage, your equipment is safe. So these parameters you should always keep in mind. Now, equipment shall withstand is an important subject. Each equipment, how much voltage an equipment can withstand, has been included in the subject of IEC, insulation coordination. Insulation coordination, I don't want to read it. Probably once when you look at the video, you'll be able to understand. So insulation coordination is a subject which talks about how the insulation between two live conductors or between live conductor and earth can be maintained in an equipment, so that, or in an installation, so that maximum life can be expected. Now, there are several parameters which is influencing the insulation level of our equipment, such as insulation coordination because of clearance, temporary over voltage, impulse withstand voltage, steady state peak voltage, recurring peak voltage. There are, pollution, degree of pollution, microenvironment, so many parameters are influencing the insulation of the equipment, but out of these parameters, the one parameter which is important is impulse withstand voltage. So the rated impulse withstand voltage is considered as the base for insulation coordination. What is this impulse withstand voltage? You have here a sine wave, and there is a transient over voltage, let us say, which is created due to a surge, maybe a lightning or some kind of switching action. Now, the standard wave shape, which is recommended in the standard for UW, voltage impulse withstanding capacity, is called as 1.2 to 50 microseconds. It means this voltage is generated in a laboratory in order to test the insulation level, short time insulation withstand of an equipment as a voltage waveform. And this voltage waveform looks like, in 1.2 microseconds, it goes from zero to peak. Let us say the withstand voltage is 5 kV. So the voltage goes from zero to peak in 1.2 microseconds, and it comes to half of the peak. Let's say 5 half is 2.5. So 0 to 5 kV in 1.2 microseconds, and back to 2.5 kV in 50 microseconds. And this is the standard wave shape which is used for voltage impulse test. So every equipment, the manufacturer should test the equipment with this kind of an impulse voltage. And there are 4 categories of such devices, or the electrical appliance for a 230 or a 230 400 volt, or with a nominal voltage up to or maximum 300 volt. They are categorized into 4 categories: category 1, 2, 3, 4. Say, for example, 230 400 volt, you have the category 1 as 1500, 2 as 2500, or 2.5 kV. Don't look at the comma. I think I made a mistake. It's in Europe, they do, they make a comma. So 1.5 kV, 2.5 kV, 4 kV, and 6 kV. So basically, the 4 type of voltage impulse withstanding categories are mentioned in the standard. 4 categories. Where they are applied is very important. Category 4 is a device which has to be used at the origin of the installation. That means whenever your electrical installation starts, at the mains incoming panel, all the electrical apparatus which you are using, such as the switch gears, such as the meters, such as the CTs, such as the MCBs or whatever, all these devices are supposed to have, of course, MCB probably in a large panel is not possible, but all these devices must be of installation category 4. Category 3 is equipment in fixed installation. I have some examples I will show you. Category 3 is energy consuming equipment, and category 1 is an electronic apparatus. So these 4 categories are mentioned in the standard. Now, for transient over voltage protection or surge protection, the first parameter which we are supposed to, I will switch off my video for a short time. The first parameter which we are supposed to identify or mention is the voltage impulse withstanding capacity. So here, for example, I am showing a catalog from Schneider. You can see here over voltage category as per IEC 61010. This is category 4. That means this device is, you can use it at the mains incoming panel. That is the meaning. Similarly, another MCB, over voltage category 3, means at the mains incoming, you cannot use this MCB. You have to use it at the sub switch board or at the fixed part of the installation. Another MCB, S750 ABB, over voltage category 4. That means at the mains incoming panel board, you need to have this particular MCB, not the previous one. So here, S200, you cannot use it in the mains incoming because it is over voltage category 2. The second one, over voltage category 4, means 6 kV it can withstand minimum. So you can use it at the mains incoming panel. This is from Kusum multimeter. You can see here safety, double insulation, and you can see the category here, category 3, 1000 volt AC or DC, category 3, category 4, 600 volt AC and DC. What does this mean is, this meter can be used in location 3 up to an operating voltage 1000 volt AC. Similarly, this meter can be used in location 4, that means at the mains incoming, for testing the parameters of a panel board, provided the voltage is up to 600 volt. That means category 4000 volt is not allowed. So this is how it has to be read. Another classic example, for example, elevators. Why I am specifying this elevator is last few days, the apartment which I am living has got a big problem of elevator frequent failures, and we were trying to investigate. But this I included because this is probably a good information for you. So elevators are part of fixed installation. It's not a portable device or it's not a pluggable device. It's a fixed installation. You install it and it's permanently connected. So in the one moment, I will show you. Yeah, here these are the categories. At the mains incoming, category 4 device at the fixed installation. That means your wiring is fixed. The sub switch board, the wiring, the fixed installation such as equipment like a fan, equipment like a light fitting. These are not pluggable. These are fixed equipment. Then connected device, you can have, you see here 2500 volt, 4 kV, 6 kV. These are the voltage impulses which is mentioned. Now, lift is a part of a fixed installation. The ISO standard 8102 part 2 explains about the design rules, calculation, examination and test of lift component. Because it has got various components, electrical, mechanical, electronics. Now, in this standard, if you look 5.15, it is talking about the testing of electronic components, and here 5.15 exclusions. The following devices are excluded from the testing. One of this is, for example, you can see here on the right side the table, and here this is actually applicable for optocouplers. Failure exclusion shall only be considered provided that components are applied with their worst case characteristics, value, temperature, humidity, voltage and vibration. Table 3 explains conditions under which certain faults can be excluded. Here actually optocouplers, you can see here, optocouplers are excluded from this testing. That means the entire electrical installation of the lift must be tested for category 3. One of the exemption or the only exception is optocouplers. So category 3 can withstand 4 kV. Here, category 3 device, voltage impulse withstand of the lift electrical installation is 4 kV for a 230 or a 400 or 440 volt operating voltage or a 3-phase lift. Now, the other requirement is the lift between line and the earth. 5 seconds voltage withstand between line to P is 1200 volt. This is also an additional requirement. Category 3 means minimum the lift should be able to withstand these voltages up to 4 kV transient over voltage and temporary over voltage up to 5 seconds 1200 between line and P. Now the safety issue comes into picture. All of you know that in almost all high-rise buildings, the lift has got separate earth electrode. Through the lift, through the shaft, separate earth bus bars are running and it is connected to separate earth electrode, and the network looks like a TT. Now, in a TT network, where the high voltage side and LV side, the transformer, the power supply comes from a transformer, the HT and LT side probably are separate or probably are interconnected. Now, in the high voltage side, if the HT and the LT are interconnected, earth fault at the high voltage side create high potential, please excuse about the spelling mistake, create high potential at LV side of the installation, transfer potential, resulting in failure or deterioration of the electrical system in lift. So what does this mean is, in a TT system, you are getting power supply from a transformer, and at the transformer, if the high voltage side and the neutral of the transformer are interconnected, under this condition, in case of any fault on the high voltage side of the transformer, whatever the voltage gradient which is created on the high voltage side will be transferred to the low voltage side, which will be directly applied on that particular equipment. As a result, the equipment fails. Means a voltage of more than 1200 volt may appear between line and P. As a result, degradation of the equipment will happen and equipment may fail. If we look at the quality or the life of lift electronics in our buildings, people, those who are living in high-rise buildings, they know it. Lift is always a headache. One of the reason is this one, because the lift is of category 3. Impulse voltage withstand is 4 kV, but we connect it like a TT and we don't have a control over the potential rise during a high voltage earth fault, and we don't take care of it. As a result, a lift may fail. So these are the categorization, for example. Now, category 1 device is an appliance, which is an electronic appliance, which can handle up to 1500 volt transient overvoltage. But please note that these devices are not suitable for direct connection to a public LV supply. If you are getting electricity or if you are using electricity from the electricity suppliers facility, then of course class 1 or category 1 device, we are not supposed to connect directly to the electricity supply. Now, what is this impulse voltage? There are 4 categories. These categories you can see here: category 4, category 3, 2 and 1, mains, incoming panel, switches and industrial equipment, portable equipment and electronic equipment. If we look at the electrical engineering standards, safety standards, as I said, the base for everything is equipotential bonding. Now, at the mains, between the mains, incoming and the switches or the fixed part of the installation, with respect to lightning protection, the area, the building is classified into LPZ, lightning protection zone 0, zone 1, zone. Sorry, there is some mistake. Mr. Dominic, you are able to hear me?
Yes, sir.
Thank you. With respect to lightning protection, these are categorized into lightning protection zone 1, zone 2, zone 3, whereas with respect to electrical safety, it is classified, for example, between zone 0. Sorry. Main protective equipotential bonding, then supplementary equipotential bonding, and so in this typical fashion. So equipotential bonding shall be made with respect to electrical safety, with respect to lightning protection, with respect to transient protection, and so on. Now, let us look at our appliance. We have the appliance which is connected with a line, neutral, and earth wire. Then we have imagine our equipment, the appliance is having a withstand voltage, UW, that means the voltage impulse withstanding capacity is approximately 1.5 kV. Now, what do? We have to limit the potential difference to this equipment to a voltage lesser than its withstand voltage. That means between the line and neutral, the equipment, the appliance can withstand only up to 1.5 kV. If the voltage is more than that, of course, your equipment will fail. So what do? We have to limit the voltage which is going into the appliance to a limit less than 1.5 kV. Imagine at a typical condition, due to some reason, probably due to a capacitor switching or some operation, a voltage of 5 kV is coming between line and neutral. Of course, our equipment will fail under this condition. What do? We have devices called as SPDs, which are connected in parallel to the line, between line to neutral, for example, between neutral to earth, for example, between line to earth, for example. In this particular case, I have shown 3 devices which are connected in parallel. And these devices are having a parameter called as voltage protection level, or indirectly, it is the voltage with which the device is able to limit, or higher voltages are limited to this particular level. Imagine we have 3 devices connected in this lines, and these are able to limit the voltage more than 1.5 kV. So once when the over voltage reaches this particular equipment, the devices are able to clamp the voltage to 1.5 kV. As a result, your appliance is safe, but due to this clamping, the current which is supposed to flow, it will flow through the SPD and it gets distributed throughout the line. Why the current is flowing? Because in order to limit the voltage to less than 1.5 kV, the impedance of this device is reduced to a lower level, because the device is offering a low impedance for a short time or within a short time. As a result, the current is flowing through this particular device, and we create a situation called as equipotential bonding. So the current which is flowing through these devices, it can be either of 8 by 20 microseconds or 10 by 350 microseconds. In the last seminar, we discussed about the difference between 8 by 20 and 10 by 350 microseconds. Of course, the video in short 2 to 3 minutes videos has been uploaded in our blog. You can have a look and find out what exactly 8 by 20 and 10 by 350 microseconds meant. So basically, this is how your appliance is protected. So you have an appliance. Most important, we should find out how much voltage this appliance is able to withstand. We are making an SPD connected between lines and the earth, or between lines in some typical fashion, and these devices are having a parameter called as voltage protection level. These devices will limit the transient over voltage to that particular limit. As a result, your appliance is safe. This is what about SPDs. And what are the components? What is inside an SPD? SPDs are device contains at least one nonlinear component which is intended to limit surge voltage and divert surge current. For example, it has got sometime MOVs or silicon avalanche diodes. MOVs internal, you can see here the internal construction. It has got metal oxide grains in ceramic. Anyway, our idea is not to educate what is an MOV, and our idea is to find out how it works. So there is a voltage and voltage and time characteristics. Imagine the transient is going to a very high level, the maximum limit I am not showing, probably the voltage is very high. These devices are offering a very low impedance because it has got a nonlinear component inside. Suddenly it changes its characteristics. It offers a very low impedance. As a result, the voltage is limited. Voltage between the terminals are limited to a low level, and this is called as clamping voltage. And the devices which is doing this kind of a job is called as voltage clamping type device. So a metal oxide varistor, it is clamping the voltage. It is not allowing the voltage to go beyond a certain level between its terminals, and these are called as voltage clamping type device. Similarly, there is another device which is called as a voltage switching device. Examples are spar gaps, GD tubes, horn gaps, and so on. These devices are operating in a different characteristics. Say, for example, you have the transient over voltage, which is, as I said, the maximum limit is unknown. These devices will work like a switch. Under normal condition, the switch is off, it is off, and whenever the potential difference is up to the voltage protection level or spark over voltage of that particular device, the switch is on. As a result, your line and neutral, for example, is short circuited. So these devices are called as voltage switching type device. It acts like a switch. Up to its spark over voltage, it does nothing, and once when the voltage reaches the spark over voltage, the device will suddenly work like a switch, and it connect both the terminals. As a result, the transient over voltage between the lines or wherever it is connected, it becomes almost near to zero. So there are two kind of devices with respect to characteristics which is used as SPD. One is the voltage clamping type device, and the next one is voltage switching type device. Now, what you are seeing in the picture are the SPD components. So, some of the SPD components probably you can see in the manufacturer's catalog. These are voltage limiting components. These are voltage switching components. The third one are a combination of a series of voltage switching and limiting component. Here, the fourth one, parallel voltage switching and limiting component. So, all these combinations are possible. With all these different configurations, SPDs can be made. Now, both these devices, voltage clamping type device and voltage switching type device, how does it operate? Imagine you have the line, neutral, and P. The line, neutral, and P. We are using an MOV type device, metal oxide varistor type device. And how does this device operate is very important or very interesting to understand. You have the voltage on the you can see here kV, and you have the time. You have the transient over voltage, which is shown as the dotted line here. These devices are called as voltage clamping type device, means it is clamping the voltage to a level, let's say, for example, 1.5 kV. After the transient, that means at this end of the transient over voltage, once when the impulse voltage reaches the nominal voltage 230 volt, the MOV is out of circuit. That means there is a high voltage. This device is limiting the voltage to 1.5 kV. Once when the transient over voltage is lesser than 1.5 kV, and if it reaches 230 volt, this device is automatically out of the circuit. Nominal voltage is applied to the appliance, so directly 230 volt goes to this particular equipment. The advantage of this device is it's fast and there is no follow current. We will see the follow current later on. This device is temporary over voltages will lead to failure. So MOVs are having some advantage, it is having some disadvantage. The disadvantage is the temporary over voltages, such as imagine you have an MOV of 300 volt. If the voltage is more than 300, let's say 310 or 320 for some time, these MOVs may fail. Second is spar gap. Imagine in the same place, we have a spar gap. Please understand that the power supply is coming from a transformer. Probably you have a long line. The neutral also goes back. I have made a TNS kind of a system. You have a spar gap. The transient over voltage is something like this on the dotted line. The device is acting like a switch. That means once when the spark over voltage is reached, this device is acting like a switch. Your line and neutral is connected. It is like a short circuit. It is connected. After the transient here, once when the transient over voltage is over, once when the impulse voltage reaches the nominal voltage, the spar gap is still in short circuit condition, very dangerous. The spar gap will be in short circuit condition. As a result, what happens is the short circuit current of the network starts flowing through this particular device, and this device or this short circuit current, which follows the lightning current or which follows the transient current, is called as follow current. So short circuit current from the transformer will flow through the shorted spar gap. Then if this current is flowing for a longer time, actually we are in trouble. If the follow current, if not stopped, will create further failure. The advantage of a spar gap is it can handle high energy, whereas the disadvantage is it is slow. It is having a parameter called as follow current. It will also deteriorate after every strike. This is also written in the standard spar gap. After every spark over, some portion of the metallic electrolyte, it melts and it changes the characteristics. These are documented in this standard. So each and every of these component has got its own advantage and it has got its own disadvantage. So say for example, an MOV, the advantage is it is faster. Disadvantage is it will die of its own whenever there is a temporary over voltage. Advantage of a spar gap is its high energy handling capacity. It can handle large current, but it is slow. It is having follow current and it is having deterioration after each and every surge current. So each of these devices have its advantage and disadvantage. Now you are seeing an MOV. If you look at the symbol of an MOV, you will see in this fashion an MOV in a box. What does it mean is inside the box, there are some protective device 1 and 2. Not only an MOV, there are some protective devices integrated into it. Then only this combination can be called as a SPD. SPD is not just MOV. SPD is MOV plus its protective device. Number one, thermal fusing element and the monitoring of the thermal fuse. That is what is written in 1 and 2. What is thermal fuse? Thermal fuse is SPDs, MOVs always fail in short circuit mode. In the sense, at the end of life of this device, it creates a short circuit. Now, thermal fuse is to disconnect the MOV once when the temperature is higher than 80 degrees centigrade. There is a thermal fuse, which is actually a silver soldering and a spring mechanism. Almost all manufacturers follow the same system, soldering and spring mechanism. Under this spring mechanism, once when the temperature of this combination is more than 80 degrees, the silver melt or the soldering element melt and the spring remove the MOV from the circuit. So temperature higher than 80 degree is due to any temporary over voltage above UC or due to aging. So basically, MOV based SPD means it has got an MOV plus it has got some safety features integrated inside. It has got a thermal fusing element, and nowadays the MOVs, the SPD also have got a HRC fuse inside. Now, once when it comes to the market, this particular part, the silver soldering and the spring mechanism, is the very critical part of an MOV based SPD. That means the efficiency of this protective device or this protective mechanism decide predominantly the cost of that particular SPD. In the market, you will get a lot of SPDs nowadays made in China, but somebody buys it, put a brand name and sell it in India at a very cheap price. Especially these cheap SPDs are sold for solar PV. Be careful, the protective mechanism inside may not be efficient. It may lead to short circuit and it may lead to failure of your or fire in your buildings. So here is the symbol on the left side, MOV based SPD, spar gap based SPD, and spar gap and MOV in series. This is silicon avalanche diode SPD and spar gap SPD. These are the typical examples. These are called as single port SPD. Single port SPD means it has got two terminals. One is for one line and the next one is for the other line. Whereas another category of SPD is called as two-port SPD. That means there is in a two-port SPD, it has got an input and output terminal. So there is an input and there is an output terminal either in this fashion or in this second fashion. So these are called as two-port SPDs. Coming to spar gap, how it looks like. One of the simplest form of spar gap is two metal electrode and an air in between. Spark gap. Spark over is going to happen between the electrodes or between the metallic conductors in air. One of the oldest construction of spar gap was something like this, and these spar gaps, you can see here the construction, and there are some holes provided on the spar gap. And what this spar gap or how the spar gap operates, something like this. The spark which is created inside the gap will blow out as a flash, for example. During a current flow, the spark gap blows hot ionized gases through the holes provided in the arrestor. Actually, these arrestors are discontinued several years back or several decades back, for example. But why I am showing this is these devices are still sold in India because the OEMs in India, they don't look at the safety parameter of the component. They always look at the price part of the device. As a result, these devices are still sold in India. You can see some manufacturers, those who have discontinued such product in their European market, but still selling in India. Be very careful. Don't use an exhausting type spar gap. It's a very old technology, and if you are connecting this kind of a device in your panel board, you have to be very careful. You have to keep these devices away from your conductive parts such as bus bars. And in 2000, during 2000, sealed spar gaps came into picture in the market called as encapsulated spar gap. That means the blowout is not coming out of the device due to various technologies. The arc which is created is encapsulated inside the device. One of the initial technology which has come is called as graphite multi-disc technology. That means there are several graphite electrodes in series or parallel connected inside. So these devices, actually it has got a funny principle, or it has got a funny parameter. This graphite electrode has got a graphite powder inside. So if you shake the device with your hand, probably the carbon powder inside the spar gap, it accumulates in one portion of the spar gap. If it accumulates in one portion of the spar gap, and now if you test the spar gap with this kind of a spar gap, a protective tester, SPD tester, if you test the spar gap, what happens is the parameter, the voltage protection level keep on changing. If you shake the SPD on the right side, probably the voltage protection level is 1 kV. If you shake it on the left side, probably the voltage is 2 kV. So it keep on changing. Such devices are also sold in the market. Please be very careful. So we were always, trying to write that these kind of spar gaps, if you are using, don't shake the spar gap, because if you shake it, its parameter will change because of the carbon powder. The conventionally, there are the devices are classified into spar gaps or GD tubes, voltage switching type device, metal oxide varistor, and TVSS. If you look at a small comparison between these three devices, you can see the advantage of spar gap is high energy handling capacity. It can handle 10 by 350 microseconds, and its problem is voltage clamping, high voltage clamp, and follow current. MOV, high current capability, low clamping voltage, but significant overheating during conduction. And the TVS, like the silicon avalanche diodes, these are lowest clamping voltage and very low energy absorbing capacity. These three are the components which is used in an MOV. You are seeing one of the construction of a SPD, say for example, a single thermally protected MOV means an MOV, and here there is the spring arrangement which I have told. This is one of the method. The second method is parallel MOVs. A lot of MOVs in parallel series combination, silicon avalanche diodes in parallel series combination. So SPDs are made with so many techniques. How does it operate is more important for us. Imagine we have the main distribution board, three-phase incoming, neutral incoming, and then you have the PE conductor. So basically on the left side, you have the incoming, and on the right side, you have the installation. Imagine I have 4 SPDs connected in this combination, which we call as 3+1. 3+1 means 3 SPDs between 3 line conductors to neutral and 1 SPD between neutral and the earth. In this combination, imagine there is a lightning strike. Lightning strike is creating a high potential on the earth, for example. So the earth potential is going up. How does this device operate? Imagine I have 4 spar gap based SPD with a voltage protection level of 1.5 kV. It means once when the potential difference between the PE terminal and the neutral terminal is more than 1.5 kV, this device acts like a switch. Now, imagine the voltage is more and this device had acted like a switch. As a result, your earth and the neutral are shorted. Actually, it is not 100% shorted, but you just imagine that it is shorted. As a result, what happens? Potential difference between PE and neutral for the time being has become 0. But the same high potential of the earth is now applicable. It is transferred to the neutral. Suddenly, between the neutral and the other phases, the same potential difference is applied or it is applicable. As a result, these 3 devices also will switch on and it connect neutral and the other phases. So now we have created a situation which is a perfect equipotential bonding. Means the Earth is connected to neutral, neutral is connected to the other three phases. So basically everything interconnected. As a result, there is no potential difference exist. Even if there is a potential difference exist, the potential difference is lesser than the voltage impulse withstanding capacity of the connected load. So this is how an SPD works. And you must understand that this kind of equipotential bonding is happening in few nanoseconds or in few microseconds. It's very, very fast. So there is no device which can detect the transient and switch off your appliance. The only opportunity or the only chance is to have this kind of a device. Now, how this device works during a lightning strike in your building? You have a building. You have a power line coming from a transformer. The star point of the transformer is connected to earth, and here this green line means under normal condition everything is at reference to the earth potential. You have a very safe system. Imagine there is a lightning strike. The lightning current flows through the down conductor. It flows to the earth. As a result, what happens is some portion of the building will have a high potential, some portion of the building will have a different potential. It depends on various parameters. So within the building, there is a potential difference created, and what you should do is to create a equipotential bonding in your building. If you created an equipotential bonding in your building, there is no potential difference between different metallic parts of the building. As a result, the building is safe. But look at the power line, which is coming from the transformer. The power line is carrying 230 volt. Maybe due to lightning, the potential of your building is, let's say, 50 kV. It can be even higher. So potential of every metallic object in your building is 50 kV, and the line is only 230 volt. So there is a transient overvoltage between the earth and the connected line. So what do? We connect SPDs at the mains incoming panel. You make an SPD here. This is an SPD, and the SPD is creating equipotential bonding between the earthing and the connected line. As a result, the line which is circulating inside our building is having the same potential of the earth. So a perfect equipotential bonding is created. As a result, all the equipment inside our building are now safe. Now, once when you make equipotential bonding with an SPD, the most important parameter we should understand is called as UW, voltage impulse withstanding capacity of your equipment, of your connected load. Now, for example, I have used one type of connection. Here, in the previous connection, I have shown 3 devices between line to neutral and 1 device between neutral and earth. In this case, I am connecting 3 devices between line to earth. The 4th device is between neutral and earth. So this kind of connection is called as 4 plus 0. To understand it better, we can call as 3 plus 1 connection and 4 plus 0 connection. Both are a little bit different. Now, lightning is always a common mode phenomena. For a common mode phenomena, this kind of a connection is much more efficient. The 4 plus 0 connection is much more efficient than a 3 plus 1 connection. But then, depending upon your network, like you are using TT or TN, where the earth fault protection is implemented. So based on several questions, we should decide the type of connection which has to be implemented in a typical building. Now imagine your building has got a lightning, perfect equipotential bonding. There is an SPD at the incoming, equipotential bonding between the earth and the incoming line. Everything is safe. The IS IEC 62305 part 4 says, out of the 100% current coming from the lightning, approximately 50% goes to earth through the earth termination system, and 50% of the current is diverted through the connected metallic services. Metallic services are, for example, metal water pipe, metal gas pipe, electricity supply, 3-phase and the neutral or the PE conductor. Then you have a telephone line or so on. So 50% of the current is diverted to the power line or to the connected services, provided there is a long connected service line. long connected, the length, let's say, for example, if the line is 200 meter, 300 meter, then large amount of current flows through this particular line. But imagine a situation where the transformer is very close to your equipment, very close to your building. Under that condition, 50% current may not flow through the LV connected service, because there we have to make a separate calculation. We will talk about it probably in the part 2 of that particular our seminar. So SPD categorization. The SPD, which is connected at the mains incoming switchboard or mains incoming panel, they are called as type 1 SPD. I have put surname because we have the habit of in German standard, the old standard SPDs were called as class B, class C, class D, very old standard. Since we have the habit of having, calling these devices still in the old name, I just put as a surname, but this is actually an invalid name. You should call as type 1, type 2, type 3 SPD. Type 1 is an SPD which is tested with an impulse current of 10 by 350 microseconds. Type 2 is an SPD tested with an 8 by 20 microseconds. Type 3 is tested with a voltage impulse of 1.2 to 50 microseconds. These are the first two are current impulse, and the third one is the voltage impulse. We have explained about 10 by 350 and 8 by 20 in the previous seminar. I don't want to explain it again. Now, type 1 SPD, how it is tested? 10 by 350 microseconds current. Imagine you have a 10 kiloampere SPD, type 1 SPD, 10 by 350. That means the SPD is tested for 25% of its rated current, means 2.5 kV, 50% of its rated current, 5 kV, sorry, 2.5 K, 50% 5 K, 75% 7.5 K, and 100% 10 Ka. Positive and negative impulses are applied to the device, and the device must be able to withstand. These devices are suitable for lightning protection zone 0 to 1, between zone 0 and 1. These devices must be installed in the main switchboard. Second type of SPD is type 2 SPD, which is tested for 8 by 20 microseconds. These here, the devices are tested for nominal discharge current 20 times, maximum discharge current 1 time. The application is between lightning protection zone 1 to 2, sub switchboard. Type 3 devices are closer to your equipment. We will see more into this type 1, type 2, type 3 in the next part of the seminar, part 2 of the seminar. But what you should understand is these type 1 SPDs are also tested for type 2 parameter. So generally the manufacturers call this as type 1 plus 2 SPD. By looking at type 1 plus 2 SPD, don't be more interested. It is a type 1 SPD, but tested for type 2 parameters as well. More than type 1, type 2, you must check how much current it can handle. For example, type 1 SPD 100 kiloampere, type 1 SPD 50 kiloampere, type 2 SPD 12 kiloampere. So we should, sorry, it's not type 2, type 1. There is some small mistake in my presentation. So like this, you should always check the current parameters as well. I'm trying to show 3-4 type of SPDs, which is used or which we sell in the market. For example, the first one is called as, the name is, trade name is Strixorb. It's a bus bar mounted SPD, which is having a lot of advantage, which I will show in the next slides. For example, one of the models, Strixorb 80, OCPD means the SPD. When you connect it to a line, it requires a backup protection, and the backup protection, it can be up to 1600 amps ACB, for example. The short circuit current is 80 kiloampere. The nominal discharge current is here, follow current IFI is not applicable. That is, I'm just showing some of the parameters of this particular device. The second device is called as phase gas discharge tube. The model number is this one, Protect T1S. Here, the OCPD, overcurrent protective device, is 500 amps GG, means HRC fuse. Short circuit current rating is 100 kiloampere. Follow current interrupting is 100 kiloampere. Parameters of the second device. The third device is called as multi-gap tube technology. In this case, there is with inbuilt backup protection. There is an additional fuse integrated inside the device. Model number is Protect T1 SF, for example. Here, the OCPD not required. The backup protection is not required. Short circuit current rating is 75 kiloampere. Follow current rating is 75 kiloampere. Another device, Protect T1HS. Here, the device require a 315 amps backup fuse. Its short circuit withstanding capacity is 50 kiloampere. Follow current is not applicable. So why I am showing these parameters are, all these SPDs are type 1 SPD, but it is also tested for type 2 parameters. So we can call it as type 1 plus 2 SPD, but basically the main categorization is type 1 SPD. All these are tested for a 25 kiloampere impulse current. The current parameters we will discuss in the next upcoming seminar. So all these SPDs are tested for 25 kiloampere. What I wanted to show you is the safety parameters, because all our seminars, we are more talking about the safety more than other parameters. So for safety, this device have got a backup protection, which is 1600 amps. Second device having a backup protection 500 amps. The third device do not require any backup protection. The fourth device require up to 315 amps. So based on the device, so many type of SPDs are available in the market. Type 1 SPD, when you buy or when you select an SPD, you must understand your application and you must select the SPD appropriately. That is what I wanted to explain. Same performance, same impulse current, but different parameters are available. Now, for example, StrikeSorb. This is actually a very special SPD, which is having a large, you can see here, a large thermal capacity electrode to absorb the heat. It has got a metal oxide single distribution class metal oxide varistor, and the construction looks like something like this. The SPD can be mounted on the bus bar. The advantage of this SPD is, next seminar, we will see the disadvantage with the connecting wire length. The advantage of StrikeSorb is, since we are eliminating the connecting wire, the performance, the ultimate protection level of this SPD is much better than a DIN rail mounted SPD. Say, for example, in a DIN rail mounted SPD with a connecting wire of, let's say, 250 millimeter square, here you can see the surge current on the x-axis and you can see the let through voltage. So depending upon the surge current, the effective voltage goes into your equipment is higher and higher. Say, for example, for a surge of 30 kiloampere, up to 12 kV voltage goes into your equipment. That means your equipment is ultimately not protected. It is because of the wire length, because a DIN rail SPD, to connect, you need a little bit of wire and a HRC fuse. Whereas in comparison, the bus bar mounted SPD here, it is connected directly on the bus bar. As a result, the protection level is absolutely less. You get very good protection. The number two, these SPDs are high energy SPDs. Sometimes people say only spar gaps can handle high energy, MOVs cannot handle high energy, which is wrong. These devices, say for example, StrikeSorb 80, it is class 1 SPD 25 kiloampere, class 2 up to 200 kiloampere it can withstand. These devices are also used for multiple strikes, let's say 100 kiloampere, 65, 100 times 65 kiloampere, 2000 times 10 kiloampere, 250 times the long duration strike, something like that. So the SPD StrikeSorb, it's a very special SPD which is having a response time of less than 1 nanosecond, very expensive, but for very specific and very big application. In comparison, the other SPDs are, you need a backup protection sometime. The modern ones doesn't need a backup protection. It has it require a wire to connect and so on. We will look into these parameters in the next slide. So basically, the devices, different type of devices, partial, the first one, it can handle 10 by 350, 8 by 20 and so on. Let me skip these slides. This I already explained. But the most important parameter or the most important point which I wanted to tell you is when you are using an SPD, the safety of SPD is very important. I'm showing you a video where it is in a petrol pump. Technician is checking the power panel. You see what happened? So basically, they are checking the panel board, and suddenly there is an explosion. This explosion is because of an SPD. Now let me switch off the volume. Okay. Now this explosion, what has happened is, the previous day, neutral of the power supply has been disconnected, and some of the protective device disconnected, and there was no supply. And this gentleman, without understanding that there is no neutral, he switched on the incoming panel board, or he's asking someone to switch on the incoming panel board, and the SPD exploded. So SPD is a good device. It can protect your electronics, but if you don't select it and install it properly, this device can also be deadly. So please be very careful when you select the SPD. By this, I would like to stop today's presentation. Probably we can go for a question answer session, and the other parts of the selection we will discuss in the second part of our webinar, which is I think in 2 weeks. So with this, let me stop the presentation. Over to you, Mr. Dominic.
Thank you, sir. Thank you. Ladies and gentlemen, we have the part 2 seminar webinar coming up in the last week of this month. Lakshmi would have probably posted the link for you to register for the part 2. So if not, I request Lakshmi to just post the link that where people can register. And let's take up the question answer.
Mr. Dominic, sorry to interrupt. Mr. Dominic, sorry to interrupt. A lot of questions are coming for what is this solve and how the safety audits are done.
Okay.
If time permits, we can have a small presentation on how solve is.
We can do it, sir, because solve I can find a lot of interest being shown. Can we talk about what is this solve and how it can help all the electrical audit engineering, sir?
Of course, yes. We have Mr. Vinod with us. So Vinod, you can unmute yourself and you can share your screen, and you can just make a demo of how this is carried out.
Yeah. Okay, sir.
So Solve is a digital platform which we were developing for the last 1 year or 1.5 years. It is an interactive platform to ensure that the electrical installation is made safer, or the electrical installation is working fine. You can share your screen and you can open the browser.
Yeah.
Over to you.
Actually, this is can I start, sir?
Yeah. Go ahead.
Yeah. This is a solve platform which we are developing in an artificial intelligence form. So we are having a small introduction about this. We are having 3 modules. One is testing, inspection and certification part, and one is rent meter. So you can rent meter in this platform itself from us, and also you can buy meters in this module. So whatever meters which is required for your electrical safety audit, we will be selling from different organizations.
The idea is here. The idea is sometime for testing a low voltage electrical installation, you need meters which is very expensive. For example, a fault loop impedance meter to test, let us say, a large installation. Sometimes the meter is costing 8 to 9 lakh rupees, or let's say 10 lakh rupees. But to test the complete installation, you need sometime total the cost of the meters probably 30-40 lakh rupees, and the people cannot invest that much amount. So what we are doing is we will have meters, and our partners or the members of Solve can rent the meter. Of course, everybody cannot become a partner. Some trained people can rent the meter so that we will send it to them. They can do the testing and they can upload the data into the website. Over to you, Vinod. You can explain.
Yeah. So in testing part, we are having 3 modules now. So LV system safety audit and lightning protection system survey and electromagnetic compatibility assessment. So with which we can go for LV system first. So here we have generated one report. So I can show you how it works. So this part will be having basic information about the site, what kind of the site name and details of the report, whether we are going to do a root cause analysis or a electrical safety audit or periodic safety audit, like that. It will be having several classification in that. So again, whether it will be having a first verification or it's a domestic or it is a commercial parts, like that. We are having basic details in this area, and whoever the inspector who is going to carry the electrical safety audit will be, those details will be, we can enter here. So like
basically the first part is basic information. What kind of installation it is, how big it is, how the electricity is coming, what kind of network and all. So basic information.
So next information will be your supply characteristics. So with which, based on your incoming EB incoming, you can able to give the name based on that, and you have to give specific type of earthing in this fashion. Suppose if you don't know the earthing means, you can highlight as others, and you can give the details of connections which is given to the transformer. And like
basically we for the initial development, we took the format of IEC 60364, but it is not just a format. The data are collected with this format and it is processed, and finally the idea is to tell the client which are the areas risky for you. You know?
Yeah. So with which we can able to give test results also in this software, and which can able to, this is artificial intelligence software we are having that. So if you enter the test details like nominal voltage and fault loop impedance, it will automatically give you the current, maximum prospective fault current, which means maximum fault current in which your circuit can drive. So after that, it can also give your disconnection time when fault flows. So based on that, if you have alternative supply also, you can give the details of the same.
The information from the mains incoming, that means from the transformer, the information from the alternate supply. Let's say, for example, you have 3 DGs and 3 transformers. All the information can be put into the software. After the alternate supply, what exactly it is? Can you go down a little bit?
Yeah.
Then here the parameters like the size of the conductor, length of the conductor, these are actually we have to measure it and we have to put the actual parameters. That means it is not filling a form. We have to test, and with the sequence we have to keep on filling the form. The next one, please. So this is, we are making it interactive in the sense, imagine in a client's premise, there is an electrical engineer who is doing the test, and probably the senior officer wanted to know whether this is correct or not. He can put the comments into the software so that both of them can look into the comments, they can answer or they can discuss in between, and if they need, they can also make retesting and so on.
This part.
Yeah.
This is the comments part.
So once when a comment is put, then that particular part develops into comment, the parameter wise comments are included. Can you go to the next part, inspection part? So at the top, what you are seeing is basic information. Basic information, can you go to the top? Basic information consists of a lot of information. Then supply characteristics. This particular part, which as I told, it is copied from the IEC 60364, but we have put a lot of effort and a lot of information into it. The inspection basically it checks the physical inspection of the entire electrical installation, such as the shock protection, such as fire protection, and so on. And the fourth part is the testing part. Fourth is the testing part. So testing, you see here, a lot of parameters need to be tested, detailed testing. And once when you do the testing with a meter, you are supposed to fill up the form. Can you go to the next module? Also, the final summary. Finally, the summary is you will get the result and you will be able to find out how many circuits are in good condition, how many circuits are safe, how many circuits are having problem, and so on. Now, what you should understand is, as I explained in today's presentation about the lift, if you look at the IS 732 or IEC 60364, the standard format, information about lift is not included. Whereas in our software, what we are doing is the information about the safety requirement of all the connected loads. Let's say, for example, if you put a lift, then the standard is, then the it says, okay, this lift is based on ISO 8000 part 2. Then you check these parameters like its protective bonding, its disconnection time, its insulation resistance, and so on. So basically, not only the electrical installation, the safety parameters of the entire connected load is also included as modules, so that the software gives you a very good opportunity to find out whether your electrical installation is in a good shape or not. Now, we are making it in such a way that we will be able to carry out the electrical safety investigation, or like whenever there is a fire, and if we wanted to investigate the reason for fire, this module will be able to find out the probable problems. So thanks, Vinod, for sharing this. We can go back to the question answer, Mr. Dominic.
Okay.
You can unshare. Yeah.
So you're on mute.
Sorry. Taradhal is asking, in tender specification, can we put protection audit during installation and commissioning?
Of course, yes. You can put, technically speaking, it is a mandatory requirement, design, erection, and inspection, or design, erection, and verification. So at the moment, design is there, erection is there, but testing is not included. So please include verification as well.
Satish is asking, what is the category to be used for panels which are installed on the roof of building or external areas to protect over voltage due to lightning?
Yeah, it can be of category 4.
Category 4.
Category 4 means 6 kV. Actually, this is more related, the category 4 is more related to the mains incoming. But if you have a power supply, if your equipment is fed from a power supply which is within the building, then category 3 is also accepted.
Okay, Mahinder is asking, I think you should watch the previous webinar, and this followed. We'll be sharing the record to you. You're asking right method to protect building from lightning. So that is the purpose of this webinar. So you can review the presentation of Mr. Gupta later. So we have anonymous. Normally we don't take, but however, the important is the question. On an average, how frequent it is required to replace SPD for domestic and office purposes?
Actually, if you are using or if you are selecting and erecting an SPD based on the correct methods, generally 15 to 20 years. It is supposed to give 15 to 20 years. Not only the SPD, the entire electrical installation is supposed to give an average, a minimum life of about 25 years, including SPD. So let me say 15 years. It again depends on what kind of equipment you are connecting. If you have connected an SPD very closer to a capacitor switching panel, and if the capacitor switching panel is switching quite frequently, then of course the life will be lesser.
So same person asking, do we recommend one SPD for each flat?
That is preferably the best way.
Mm-hmm. Okay. If the internal fuse of SPD is blown off, they just stop protecting over voltage. How do we know as they are just in parallel?
If the internal fuse, okay, if
If
the internal
internal fuse of
is blown
SPD
off,
is blown out.
okay, SPD has got an indication, green and red indication. So green becomes red. So you can look at the indication and change the plug of the SPD. If there is, alternatively, you can also have an NONC contact which can be connected to a light or a hooter or whatever. You can have an audio or a visual indication outside your panel board.
I request the participant to please mention your name, because anonymous question, if you take, we don't know from where the question is coming, how do we reply? So I request people to mention their name. Suresh Kumar D is asking, class or type and category SPDs are same. Some reference says type 1 used for mains, but as per category it's 3 more than 6,000 watt.
No, category is not related to SPD. Category is related to the category which I explained. Sometimes, different standards explain the same subject into different methods. Sometimes, for example, UL standard explains in a different way, IEEE in a different way. If you are talking in that fashion, I am also confused with your question. If you are talking about the category which I explained from the IEC standard, category is talking about the voltage impulse withstanding capacity. Means how much voltage your equipment. Imagine you have a TV or you have a refrigerator. How much how much voltage your refrigerator can withstand? Say, for example, category 3 means with an operating voltage 400 volt, it must withstand 4 kV. Now, once when you connect the motor to your line, we really don't know how much voltage is coming from the line. It may be 5 kV, 10 kV, 20 kV. Now, the installer or the owner of the building must ensure that when you buy the motor, you know that your motor can withstand only 4 kV. But once when you install the motor at your house, you must see that the transient over voltage going into the motor is limited to less than 4 kV. That is your responsibility. That is how it works.
Sir, Sunal Seth is asking, do we need to take any redundancy for SPD in main panel? Are there any chances of SPD failures?
Chances of SPD failure, of course, most of the time SPDs are failing due to temporary over voltages, especially the MOV based SPDs, and the spar gap based SPDs, of course, due to a wrong selection of a backup fuse, due to a wrong follow current or short circuit current. Of course, SPDs may fail. It can also fail due to deterioration. Now, for redundancy, we have on the second part, we will discuss this particular subject. There are subjects called the priority to continuity of protection, priority to continuity of supply. If you look at that particular part, you will be able to understand how it is handled.
So, does SPD have any number of operation, any limitation for operation?
Generally, for example, a type 2 SPD, I nominal 20 times. Let us say a 10 kiloampere type 2 SPD of I nominal current 10 kiloampere. It means the SPD it must withstand at least 20 strikes of 10 kiloampere. But technically or generally, a surge of 10 kiloampere is actually a very high surge. In normal, switching surges are of the order, very low level. In that case, it can handle multiple strikes. So I have shown in the case of a strike orb, it is tested for 2000 strikes of 10 kiloampere. 2000 strikes. 2000 strikes of 10 kiloampere probably will take 20-30 years in a normal environment.
Santosh Dasari is asking, type 1+2 SPD category also exists? Actually,
it does not exist. Only type 1, type 2, type 3 exist, but manufacturers are free to use it because if imagine I have one SPD and I have tested it for both the parameters. I have passed the type 1 parameter and the type 2 parameter. So I have the freedom to call it as type 1 or type 2. Generally, people call as type 1 plus type 2 because it is satisfying both the technical requirements.
The very interesting question from Imanshu. Because this is something very interesting and very regular. We are having installation of sensitive CCTV installation system, including PoE. power over internet switches. During rainy season, maximum devices got damaged. As per OEM, these equipment got damaged due to voltage surge. Need your suggestion to protect these equipments.
Yes, actually, one of the fastest moving SPD in our for us is CCTV protection, because CCTV, the recorder is inside the building and the cameras are always outside the building, and sometimes are very expensive. Due to lightning, as we always say, there is a ground potential rise, and or due to some kind of EMI effect, the sensitive electronics can fail. In a CCTV camera with PoE, of course, the SPDs are available. It is Cat6e SPD, which will protect for both the signal line and the internal the power lines are protected. Actually, nowadays all the CCTV cameras are protected with an SPD. Closer to the camera number one, closer to the recorder number two. So sometimes both the places, both the locations, these Cat6 SPDs are used.
So you have under the Cape Electric banner, you have SPDs.
Yes. That is one of our biggest business. We have an association with Raycap. Raycap is a German company, one of the largest manufacturer of surge protective device. We are getting the SPDs from them, and we install it. We design the SPD system and we install it. We are one of the leader. As I said, we started our SPD business in 1997, so almost 25 years now, and we have hundreds or thousands of SPD installations. But as I said, one of the risks which we always face is in an existing installation, especially for power line, people buy SPD, but there is no space to install the SPD, and then we are supposed to or forced to use a long wire to connect SPD. As a result, it may not work. We will discuss it in the second part.
Okay,
So,
sir. How to check?
with respect to SPD, of course, we have hundreds of SPDs for power line, hundreds of SPDs for data line, signal line, instrumentation line, coaxial line, and so on.
So Cape Electric has all the solutions for SPDs, whatever the equipment is, low voltage, high voltage. Cape Electric has SPDs with them. Okay, how to check 4-pole SPDs working in normal condition?
To check the
Another
healthiness of SPD, you need to have an SPD tester. In between, I was showing on the picture, there is a handheld SPD tester. We call it as universal SPD tester. Any brand, any SPDs, you can check the 1 milliampere voltage of an MOV SPD or the SPAR gap based SPD. The SPAR core voltage can be tested. There is a handheld device.
So Mulugu Chari is asking whether do you have a branch in Hyderabad to buy the meters?
We have a branch in Hyderabad, but these activities, especially solve-related activities, we are at the moment handling from Chennai. So especially these meters, which we are trying to, actually our business is not to sell the meters. Our idea is to sell our idea is to ensure that these are used properly by proper training and proper coordination. So sometimes people ask, I wanted to buy a meter. So we will have some link which will be directing to the companies, those who are selling the meter.
So Santosh Dasri is asking criteria for SPD backups, OCPD. Rating is only for the model on type or any other criteria, sir?
Of course, there are other criteria as well. We will discuss it in the next
in part 2.
Webinar, part 2.
Okay, Kiran Pandey is asking how to protect the router or dish TV cable connected appliances from the lightning.
Yes, for router and dish TV, there are you need to have SPDs. The SPD which I explained today is mostly about power line SPD, but data line, signal line, coaxial line SPDs are also there. You need to install the coaxial line SPD for your application, or data line protection for your application.
So anonymous asking at least 8 to 10 questions, but I'm not taking your question. You can write to Mr. Gopakumar directly. We have mentioned the email because I would like to have name for all the question. So I'm moving on. Ashish Shakya in some small device, I see only MOV and not fusing element in series. So will this create permanent short in case of failure of MOV?
Of course, yes. So you cannot call it as an SPD. You have to call it, if there is only one MOV inside, then you should call as MOV. Probably MOV in a box. It's not an SPD. SPD means you need to have a protective mechanism as well inside in case of an MOV.
Lingaraja Patra is asking, sir, SPD also recommended for control supply or in protection panel?
Of course, yes. SPD is required in wherever the lines are coming from outside and entering into your building. Equipotential bonding has to be carried out for all the metallic services which is coming inside. Let's say, for example, you have a CCTV camera placed outside. Its a recorder is inside the building. You need to have SPD. You need to have, for example, in control and instrumentation system, you have sensors at the field and you have the controller inside the building. So there also you need to have SPD. It is required for all different kind of lines.
Davies asking how to avail software platform for audit. So Davies from look like Alappad, either from Tamil Nadu or Kerala. Yeah.
Yes, Mr. Davis, you can, we have from our website, solvelv.com, there is a link. So you can log into that link, you can register, and once when you are approved, you can use it. But this approval process, we are at the moment restricting because we are making only for the trained people, because the basics has to be stronger to use it. That's how it is. We can discuss about it probably in a separate session.
So Satishwaran is asking, thank you for the awareness program. During the lightning strike, our complete building metal conducting parts will be in equipotential, provided we have done proper equipotential. In this case, if any person is touching the metal part, there will be some current flowing through his body on the ground. Whether people will be protected in this case.
For example, if all your metallic parts are interconnected together, then the chance of potential difference is nil or zero. If the chance of potential difference is nil, there is no current flow through the body of the person. So even if the person is touching two different metallic parts, it's safe. Nothing happens.
Okay. Satish S is asking how to size the protective device rating for SPDs which are not directly connected to the bus bar. Are these protective device can be fuses or only MCBs or MCCBs?
This is for the part 2 of our program.
Okay, you can, Satish, come join us for the part 2. You will see the solution for this. And Arshramya, can you please advise the technical specification for purchasing SPDs for domestic purpose?
We will cover it in the part 2 because the current parameters are also coming into the picture. We will cover it. I'm sorry that we have 1 hour or 1.5 hours or maximum all our programs are going to 2 hours. Within this short time, explaining the entire parameters will be very difficult.
I think most of the questions we have answered, and I request everyone to follow the link that has been in the chat, and also we'll be inviting you individually on your mail to log in, and also please invite all the other professionals, engineers, electrical engineers, because somewhere, I always feel only best practices can improve our nation. Advancement. We are still, as Mr. Gopal was saying, we are not even 5% when compared to other European or Western country in terms of best installation practices. So unless we all engineers,
we can take up. There are 2-3 more interesting questions.
Yes,
one
sir.
is Mr. Davis again. Is it mandatory to use SPDs as per IS 732? Can I answer? Yeah, it is mandatory. If your building has got the external lightning protection system, then you need to have a type 1 SPD at the mains incoming. if you don't have an external lightning protection system and an overhead transmission distribution line into your building, then you don't need a type 1 SPD, you need to have a type 2 SPD. These parts will be discussed in depth during the second part of our program. Also, Mr. Narasimha Rao is asking about LED lights. Of course, not only LED lights, all electrical and electronic appliance, the installer or the owner of the building shall ensure that the voltage goes into that equipment is lesser than its withstanding capacity, and this is achieved only by installing SPD. So SPDs are mandatory in the equipment if you want, or in your installation if you wanted to protect your equipment.
I think continuation to Satishwaran asking with reference to my previous question, even if you don't touch the metal part, is there any chance of current flowing through the floor?
If you don't touch, yes, if you don't touch, there is no chance.
Through the floor, he's asking,
Of
will
course,
the current flow through the floor?
Through the floor and through the interconnected metallic parts, there will be current flow. But in comparison to our body resistance, the metallic parts have very small, very small resistance. As a result, the current flow through the metallic parts, interconnected metallic parts, not through the body.
So
I would say, I would explain that the equipotential bonding system shall be made in such a way that the current is not flowing through the person's body. Instead, rather than through the body, it should flow through the interconnected metallic parts. If it is not properly bonded, of course, there is a chance that the current may flow through the body and the people may get killed.
Okay, I want to thank all the participants patiently listening, and I know we are timed it wrongly because there are continuous holidays. We have Varma, Lakshmi, Moharam here. So next program will be on Friday at 4 o'clock. So I'm sure that timing is convenient to you all. We would request you to join, and also I want to thank Lakshmi on the background who's handling the entire webinar. I want to thank Lakshmi for taking time on holidays, Saturday being one on the holidays. She still continue to support us. And thank you, Vinod, in explaining this all, which is catching up. People are quite interested and they would like to know more and more about it. I'm sure very soon we'll have robust, this software which are still under development in some part. So I want to thank Mr. Gopakumar, non-stop knowledge sharing, continuous. There is so many subjects that we can cover. I think entire year we can keep on talking. But however, I request all my participants, if you are a buyer of SPDs or, earthing kit and all that, please give reference or preference to Cape Electric, because when they give knowledge, I think to sustain, we need business. So they have been doing wonderful job in the country, and I urge everyone to support Cape Electric. Thank you, sir. All of you have a great weekend and safe stay, and have a good time with your family. Thank you so much.
Thank you. Thanks to all participants. Thank you. Bye-bye.
Thank you, sir. Bye-bye.